Good morning. Oh, come on, you can do better than that. Good morning. Thank you. And congratulations. You've officially made it to the final day of reInvent 2023. Now, before we begin, I'd like to ask, who here has had a great week so far in Las Vegas? Woo, yeah, almost all of you. I'd like to ask another question. Since you arrived here this week, who here has gotten paged about a Sev2 application issue? Raise your hand. Okay, a few of you, yeah. We've all been there, right? Well, I have some good news for you. You are in the right room right now. Or if you're a service operator responsible for maintaining highly performant, reliable applications, you too are in the right room. This is COP351, Application Monitoring for Modern Workloads. And today, in this 300-level session, we'll deep dive into how, with Amazon CloudWatch application signals, you can easily monitor the performance of your applications, improve builder productivity, all without manual effort or custom code. My name's Andreas Blomquist, and I'm a senior product manager here at AWS for application observability. And I'm delighted to be joined by Igor Sadukin, general manager of application observability at AWS, and Anthony Giles, executive director of engineering and architecture at JPMorgan Chase, who'll be walking us through a customer story. Now let's get started. Here's what you can expect in the next 1 hour. First, we'll just do a quick refresher on what observability in AWS looks like today. Next, we'll discuss a few of the challenges that customers like yourself may have faced when it comes to monitoring your applications, and how with application signals, we're improving that experience in AWS. Anthony will then join us to give us a customer story of how JPMorgan Chase uses site reliability best practices along with CloudWatch to improve the reliability of their applications. And last, Igor will walk us through an engaging demo of a day in the life of a service operator using application signals. Now, I know this is a 300-level session, and many of you are already experts in Amazon CloudWatch. But just to level set, CloudWatch is a native observability tool in AWS that provides the primitives of metrics, logs, and traces. And since the beginning, we've built CloudWatch with three things in mind: scale, efficiency, and resiliency. In fact, CloudWatch is the observability of choice that we use at AWS and Amazon to power our business. And like so many of you, observability is critical to how we deliver the services that you use every single day. And we've built CloudWatch based on years of best practice and experience from running our applications internally on AWS and Amazon to deliver powerful capabilities for you, our customers. From the very beginning with infrastructure monitoring to distributed tracing for applications, end user monitoring, and so much more. Now, I'd like to just very quickly shift gears here. Who here has ever flown an airplane before? Okay, a few of you. Since I was a kid, I've been obsessed with airplanes. In fact, before I could even legally drive a car, I flew an airplane. Now, who here in this room flew on an airplane to get here today? Okay, pretty much all of you. My point is that since the invention of the airplane, it's hard to imagine an event like reInvent that we're here at today in a city like Las Vegas without modern aviation. But it wasn't so easy at first. Early on, pilots had to rely on manual tools and their intuition in order to process multiple signals being thrown at them in real time in order to safely operate. And it took years of experience. And just like you all relied on modern aviation to get here today safely and reliably, your customers rely on you to deliver a fast experience. And your businesses rely on you to deliver reliable applications. And if you raised your hand at the beginning of this session, I invite you to recall that experience you had troubleshooting and getting to the root cause of that application issue. Let's dive into just a few of the challenges that customers like yourself have told us they face when it comes to monitoring their applications. The first is that it can sometimes be hard to find all of the applications and services. Today, modern aviation uses navigational tools such as radar in order to understand traffic patterns, as well as who's flying around them in order to safely operate. Similarly, today's modern applications are made up of dozens, hundreds, or even thousands of microservices, and you need to monitor all of those. But if you're not able to easily detect and discover all of those services that you need to monitor, and have pre-built dashboards in order to get to the root cause of incidents, it can be very hard. The next, just like in the early days of flying, it can be easy to face an explosion of signals or telemetry data that requires operator experience in order to know how to process. And without standard metrics for all of your applications, it can be hard for you to understand whether or not they're healthy or have a common language that's easy to understand. Next, in both flying and in building reliable applications, you have reliability goals. But if you don't have a way to assess how close you are to breaching your goals, it can be hard to know when to respond before an incident occurs, or if multiple incidents are occurring, how to prioritize your response. And last, when incidents do occur, and they will, whether it's in the cockpit or in your applications, time to respond is critical. Using disconnected tools can make it harder for you to detect issues and take longer for you to get to the root cause of incidents if you lose context when switching between multiple experiences. Monitoring your applications can be hard, and that's why we need a modern solution. Like I mentioned, today modern aviation has delivered a reliable and performant way for us to traverse the globe. And it's made it easy for people to get started with flying, even me, at the age of 14. Every plane today provides pre-built dashboards that make it easy for operators to understand how their performance, standardized telemetry, and an integrated experience that makes it easy to correlate data in a single unified fashion. Similarly, we took the years of experience operating thousands of applications here at AWS and Amazon and are so excited to bring to you today Amazon CloudWatch Application Signals, a new application performance monitoring capability native to CloudWatch. Like modern dashboards in today's airplanes, Application Signals provides you with pre-built dashboards optimized to present the most important operational data in one place. Application Signals automatically discovers all of your services to provide you, the operator, with an overview dashboard that you can easily spot anomalies and deep dive into your services and inspect all of your dependencies, all in one place without manual effort. Next, every single pilot today relies on a standard set of telemetry. Whether it's your altimeter, which tells you your altitude and rate of descent, your airspeed, which tells you how fast you're going, or your heading, which tells you which direction you're going. You as operators also require a standard set of telemetry to assess the performance of your applications. That's why with Application Signals, you get the golden metrics of APM out of the box. Volume of requests, latency, errors, and faults for every service, operation, and dependency. Again, every pilot has an objective to safely operate a plane, and you have objectives as well. That's why with Application Signals, we're introducing service-level objectives to help you assess your goals and understand how close you are to breaching them and help you to better prioritize your response early on before major incidents occur. And last, just like today's airplanes that provide correlated telemetry in a single view, Application Signals correlates your most important data in pre-built dashboards, making it easy for you to go from metrics to traces to even infrastructure, all in one place. And if you're using services like CloudWatch Synthetics or Real User Monitoring to assess the performance of your applications, you get those also automatically integrated into a single view. Today, Application Signals is released in public preview with support for Java applications. Now that you've learned a little bit about some of the challenges and how Application Signals is addressing those challenges, I'd like to invite on stage Anthony to provide us with a customer story.
Thank you, Andreas. So, who in here has played a sport? Your children may play a sport, or you may be a sports fan. It could be any sport: lacrosse, football, tennis, hockey, cricket, basketball, baseball. Well, as a former track athlete, imagine me 20 pounds later, and as a former college track coach, I have a passion for track and field. I have a passion for track and field. And what I want to tell you today is that you are a track star. You are a track star. Now, you're probably wondering, why am I telling you that you are a track star? Well, many of you in here today, you have applications that you own, that you may develop, that you support, critical workloads and products that you rely on that are in the cloud, or you may be moving to the cloud. And to the outside world, it seems trivial. It seems expected. Just like in the 4x1 relay, they have a service level objective to get the baton successfully around the track in the shortest amount of time. To the outside world, it seems trivial. It seems expected. But as you know, it's complicated. It's intricate. So many things have to go right to successfully get the baton around the track. And in this race, there are signals all around to help to determine the outcome. For example, the starter, the first leg, they go off a signal that starts the race. If they take off too early, the entire team is disqualified. You basically have a do not load error every 400 or 500 error you could think of. If they take off too late, you're probably not going to meet your service level objective of getting the baton around the track in the shortest amount of time because you introduced latency at the very beginning of the race. Every transaction is a 4x1 relay. Every customer interaction is a 4x1 relay. Every workload is a 4x1 relay. And at JPMorgan Chase, we run thousands of 4x1 relays every single day. And that is why we have 57,000 track stars, 57,000 technologists, up from about 2,000 from last year. We invest heavily in technology. $15 billion in 2023 alone. We want to make sure our athletes are the best in the world. They have the best facilities. They have the best training. Why? Because we build world-class products. With over 6,000 applications and $9 to $10 trillion of payments each and every single day, we do it for one reason and one reason only. Our customers expect us to get the baton around the track. Our customers are always number one. Our customers expect reliable systems. We work 24/7 to protect our customers and to protect the firm. And one of the frameworks that we use at JPMorgan Chase is our site reliability engineering framework to help get this baton around the track. And I want you to focus on two major things, two major areas here: monitoring and observability, and service level objectives. We ensure full visibility into our systems. We establish and defend service level objectives and error budgets. AWS with application signals as helping us to get the baton natively around the track faster. So we were able to test application signals with a real application using EKS. And what we noticed and what we found out when we did this is that there was an automatic detection of key services, again, getting the baton around track in a shorter amount of time. Automatic detection of service operations and service dependencies, again, getting the baton around the track in a shorter amount of time. Off of the key services, we were automatically able to set up service level objectives based off the key services that were found automatically. Again, getting the baton around the track in a shorter amount of time. With seamless integration with tracing, which helps you determine root cause, and a unified view with simplified diagnostics, application signals is helping you to get the baton around the track in a shorter amount of time. Now, as I pass this baton off to Igor, who will come and give a great presentation and demo of application signals, what I want to remind each and every one of you here today is that you are a track star. Do not drop the baton. Thank you.
Thank you, Anthony, for engaging an exciting use case. What I'm going to do is I'm going to show you how to be a track star in your 4x1 relay using application signals. Before we start the demo, I want to walk you a little bit through user journeys in the application signals so you understand how all the scenarios are working through the demo. So the application signals provides a set of best practices, cloud-born, cloud-native best practices to run and operate services. A lot of these practices, our builders on my team, for example, or in Amazon or AWS, we follow very similar practices. And they lead us to be efficient, resilient, drive cost of ownership down, to be bottom line efficient, right? With that frugality in mind. So this is the 3 entry points into the application signals that typically a service operator would start with. So number 1 is service level objectives. This gives you a perspective of what is really important today or right now, and if you're within your error budgets, and how are things going for most important operations in your business. Number 2 is service dashboards. So this gives you an overall view of all your services and a perspective on what may be erroring today the most, or what may be the slowest, or which dependency you should attend to. And then number 3 is a service map. This gives you a picture of your overall architecture and ability to observe how the behavior of your system changes, like new dependencies appearing, some new errors. And so this is an inspection tool that our operators use a lot to look at the behavior of the service. And then all of these, when you observe any anomaly, would lead into a service diagnostics view, which allows you to quickly identify which anomaly you want to attend to, and then immediately click through to a root cause, either it being a trace, or a user event, or a canary, or diving deeper into infrastructure. So with that, this is the demo. The demo will be a day in the life of a typical service operator. We're going to be operating a service called Pet Clinic. So this is our business, or Pet Clinic. It's written in Java using Spring Boot. The application is written in Java. And it's deployed into EKS. And our business is obviously serving customers by scheduling visits and having new customers sign up to the site and being able to be a client to our clinic. So just like a typical day in the life of an operator, I'm going to start with handling the incidents. Hopefully you don't have any, but if they occur, this is the flow. The first thing is to take care of the most important incidents for my business and then attend to them. And second half of my day may be spent inspecting my service for any anomaly that I can find, right? Not looking at features, but if I'm on call, I'm going to be spending my time looking at my service and not fighting, but rather fireproofing my service, right? That's the time I'll dedicate as an operator. So the first incidents we're going to handle is customers cannot schedule visits, and then the second one will be the sign-on problems, and then inspecting, we're going to be inspecting dependencies, and then unusual errors, things that don't show up as typical failures, and use the application signals tool to do this. So the first incident I'm getting hit with, I was woken up by an alarm, and also my customer support team saying that some customers are unable to schedule visits to my clinic, so that's obviously not very good. Not all the customers are unable to schedule visits, only some. So this is one of those brownouts that I'm going to be looking at. My starting point here is going to be the services dashboard. So I'm going to start directly from services dashboard and give you a little bit of overview of that. And then in a few clicks, we're going to be establishing a root cause. With that, let me switch to the application signals. So this is the services dashboard that was built out of the box when we enabled application signals on the EKS cluster, right? It's in the menu of CloudWatch. These are a few new entry points. So services is an entry point. And so it provides you an out-of-the-box view using those golden signals that we collected from services and their existence in the cluster. We discovered services and we built a picture of who may be failing the most, or what are the top dependencies that you're having that may be slow. Which services do you have in this cluster, right? Which application they belong to? Are they healthy? And then a lot more. So you can, for example, know that you have what volume of operations are being processed by which service is processing the most. So this statistical information you can use to inspect your application estate right out of the box. So you don't have to do anything to get this view. Now, I'm having problems with visit service today, and we actually created some service level objectives. So when you do, this view automatically integrates with service level objectives and gives you an idea which service may be unhealthy. So in this case, a visit service, by the nature of an incident, I'm already looking at it. So it already tells me that there's availability of scheduling visits. I violated my service objective here with this service. I'm going to click through this and show you the next service diagnostics dashboard. So this is focused on an individual service. And it provides you a view into all the operations that the service implements, APIs, right, that are getting called. And then automatically collects information about latency, errors, faults, volume of these operations, right? The same happens for dependencies. We'll get to that later. But these are effectively these golden signals. So this dashboard is built out of the box for you so you can see what this service is doing. So in this case, I'm troubleshooting an incident where I have availability drops. So I'm going to look at this chart that provides me a view of availability and volume. What I see here is on a normal day or normal course of action, my availability is actually 100%. And there is low rate of requests and people are scheduling visits without any problems. However, when I have some spikes in my volume, so if I have more requests, my availability drops to actually 87%, which means it's not 100% down, so I'm not entirely broken. But a few customers are unable to schedule visits, and that is not good for our business, right? So what I'm going to do is, and this is what has been hard before, and you had to build it yourself, a lot of these dashboards, but I'm going to click on this availability drop. Like this one is more pronounced. So I'm going to click directly on it. And what the system is going to do is it's going to find all the direct causes of that particular drop. Not everything that day, but only the causes of that drop, right? And so here I have a few traces that actually caused precisely that availability drop on that moment, right, in time. If I click on any of them, I'm going to go into the analysis of the trace, and it gives me a picture of what happened. So obviously, there's been a bunch of failures leading up to a call to DynamoDB in that particular instance. Again, during that time, a whole bunch of customers were served just fine. This one wasn't. So I'm going to look into that. And my goal here is to establish the root cause as soon as possible. So I'm going to click on the last call that had been made here. And I see the DynamoDB 400 exception when I call it. When I click certain exception, I see an information that says the DynamoDB wasn't provisioned at the right capacity for me to handle a spike in customer traffic, right? So I'm quickly led to the root cause, so now I know what to do, and I've closed my incident. The whole flow was built to illustrate how out of the box you can get the visibility into your services and very quickly establish the root cause of a particular individual outage or individual spike on a few customers, right? Now, again, not entire service, but now, since this is very important to your business, you can go and increase capacity, provision capacity on DynamoDB and make sure your customers are served again. So that closes that first incident for me. So I'm out of that one. Next, so I'm going to handle next incident. So my owner, pet clinic owner, called me and said their neighbor was trying to sign up to the clinic, and it was taking too long. And they weren't patient enough to wait, so they left, right? So I'm going to handle that incident, and I'm going to see how prevailing that is, and is it widespread, and how far we are. In this case, I'm going to start with a service level objective dashboard. And ideally, if I set up my service level objectives right, it should tell me I'm having this problem. It should tell me how bad is it, right? And we're going to do a little bit of root causing and dive deeper into that. Latency is a harder problem to handle than failures, typically. Let me switch back. And in a CloudWatch, click on service level objectives. So this is this other view that we have. And for this application, it's very easy to click on any operation, any service, set up a service level objective with your criteria. So we've set up several service level objectives. And the first one was availability of scheduling visits. We already handled that one, we know. And I have this one, latency of registering an owner. This is the one I'm handling right now. This is the one I heard. So here in a dashboard, I clearly see this particular service level objective not being where I need to be. In fact, since we run this demo on a recurring basis, I'm out of air budget quite deeply here, right? So I've been actually violating some customers. Again, not all, but some customers are getting slow response from my service. So what I'm going to do is, since I see this is an unhealthy service level objective, I'm going to scroll to the right and see the cause, or immediately see the operation that actually causes this service level objectives to not be in compliance, right? So the operation is adding owners. So I'm going to click on it. So right away, in application signals, I am focused on that service and on that operation, and all the other noise is removed from my view. So I'm only focused on the operation that is contributing to that service level objective. What I see here is this operation is actually has 100% availability, so it's doing fine. Like from availability perspective, there are no errors, right? There are no faults. But latency is spiking up very strangely, right? Moreover, it's not all of the latency. It's P99, right? So it's very few outliers. Few customers are getting this experience, not all customers, right? And that's why my owner's neighbor all of a sudden got this, but most customers didn't. Now, that's not good for our business that customers cannot sign up. So I do want all of them to get great experience. I'm going to click here on this anomaly, that very one anomaly in the chart, right, of latency, P99. And what it did is, what application signals did, it actually found the contributors to the P99, the one transaction that actually contributed to the outlier. Not all of them, again, not all of possible transactions that could be approximately, slow, but precisely P99 outliers, right? This is actually hard to find usually. This is the correlation mechanisms that we've built to be able to identify the precise traces that fall into those outliers. So when I click through this, I can see that I have a transaction that actually completed. Well, nothing was too bad, it just was slow. But I have some strange occurrence of something going on in the payment gateway. Now, why am I using payment? Payment gateway in this case is when you sign up to our clinic, we want to take a payment method and we want to validate it. I'm going to call validation mechanism on the payment gateway is a dependency of ours. So in this case, I'm calling that dependency. And if I look at the sequence of actions in that P99 outlier, I can see that it was tried once, and then the client library retried it. However, we didn't configure the client library to the payment gateway appropriately. So what it does is it waits too long between retries. Just default debugging or developer setup. Very typical, we deployed it. And there's probably a better way to configure that library for production with not only shorter retry, but also exponential backoff, right? And so I'm going to, again, go back to that code, fix the problem, and my customers will be signing up quickly. Now, latency is not always that easy to identify. It's not always obvious that there is a retry. You're lucky if you got it this easy. Sometimes latency is much harder to investigate, and it requires diving deeper into the infrastructure that actually run this code, right, to the process that actually hosted the execution of this line. So here in application signals, we have correlation, strong correlation to the infrastructure. Here it says, this column says hosted in, and in it we provide information, a link to the infrastructure, a container infrastructure that ran this code. So I'm going to click on it and just give you a little bit of a flavor. So if I click on that link, it leads me to Container Insights, CloudWatch Container Insights, which monitors infrastructure of a cluster. And the view I'm getting here is focused, notice here, on a particular pod instance. So this little number after the name of the pod identifies not only the node, but also the process that ran in the past, actually. It ran a while back, right? That's the P99 I'm investigating may not be happening immediately now. It may have happened in the past. So we have a history of all of it. And so when I'm looking at the performance of this pod, I can see the CPU metric, network utilization. I can see all other metrics such as memory, all of that process. So I can identify if I had any infrastructure contention at the moment of running that transaction, right? So for example, if CPU was high, I may have been competing with another process or another application running in the same process. I may want to, break them apart and isolate, right? Because they may be competing with each other. Moreover, if I want to, I can also look in the actions here, I can actually view application logs. We're not going to go deeper into it, but application logs is effectively standard output of that process. So you can see, if you're interested, and that provides you good visibility if there was any logging going on in that process that may have been unusual. You can look and identify problems in the particular instance that ran that very one transaction that contributed to P99, right? So this is the deeper investigation. So again, here we've completed the our firefighting. So all the incidents, so latency is back in shape, our availability is back in shape, and we're going to transition to inspections. So I'm relieved of the pressure I had. Now I can pay attention and fireproof my applications. So the next thing I'm going to do is I'm going to look at the new dependencies that my application took and inspect them and see how well they're performing, right? Just for my knowledge as a service operator, to be sure. What I'm going to do is I'm going to use Service Map, the inspection tool, to find that new dependency and then inspect it, right? So we're going to go back to the CloudWatch, and I'm going to click on Service Map here. So Service Map, again, this view has been built out of the box. So application signals detected all the dependencies and built this map out of the signals it receives, even if you had very low rate of tracing. Another thing I wanted to mention is all the application metrics you've seen, all the signals, they're true metrics before any sampling. So they're not relying on you tracing or not tracing. They're always 100% precise. And based on that information, we always build you the map. Even if something wasn't traced, we will know about the dependency. So this view here presents the overall architecture. There's a set of clients, set of canaries, and set of dependencies that my application has. And as an operator, I'm interested in this dependency because I haven't seen it. I haven't seen my customer service here ever calling SQS service. There's something new to me. You know, I'm new. I'm just on call, so I joined my on-call rotation, and I came in here, and this isn't something I've seen before. So I'm interested. I'm going to inspect it. So when I click on that edge, I'm presented with statistics of how well this dependency is doing, right? And so here, I actually see some low, like 6% error rate in calling the operation on, the operation that is using it is adding pets. And the operation that it uses is purge queue on SQS. And I'm seeing some errors. Not only I have not seen this dependency, but it also is producing some errors. So as a responsible owner for the service, I'm going to look into it, right? I'm going to click right here into the link next to that. And application signals, what it does is it focuses, again, in the service diagnostics page, in this case, on dependencies of that service, right? The customer service. And it focuses me on a dependency that I was interested in and the operation I'm interested in, the purge queue operation, right? So the one I need to inspect. And for this operation, we've also automatically collected all the golden signals, which is latency, errors, and faults. And so here, I see sporadically, I'm getting these strange errors on the dependency. So somebody started using SQS queue in my customer service, and I don't know why it's having these errors. So I'm going to click. I'm going to click on these spikes of errors. And here, again, I'm presented with a view where this weren't faults, they were errors. So something is not right. But I got exactly the examples of those anomalous behaviors. When I click into them, I can see that what happened here is the customer transactions actually was failed, so I should care about that. But it didn't show up in any of my reports yet, right? So I'm looking around, and I'm seeing this strange behavior in the calling in the SQS queue. So I'm going to look down. I'm going to click on this strange behavior, go to the exceptions, and see what's going on. So what I'm reading here is the purge queue operation. The SQS queue actually is set up to handle purge queues, but not as frequently as I'm calling it. This is an issue that is not very easy to catch in your pre-production. It requires a lot of events to come together to actually cause the system to all of a sudden start calling the purge queue. Apparently what we're doing is in a customer service, when we onboard new customers, we try to expedite the process. We try to expedite and make things, so we use queue to make sure the next part of the processing would happen quicker. And we're also over-aggressively calling purge queue in the hope to expedite it even more, right? There are other ways to do this, but that's what we did. And it causes this accidental behavior and a dependency that I don't want. As a service operator, my responsibility is to look around, inspect my system, make sure this doesn't happen. And now I have a tool that can help me easily identify these strange anomalies and take care of them, right? So obviously I'm going to go back and reconfigure my queue and stop calling purge queue operation this often, invent different mechanisms. So this completes our dependency inspection. We're going to do a little foray into another area. That is a very common practice that we practice internally at AWS, is looking for errors, not faults. So what that means is it may be that all of a sudden there's some bug that causes 400 exceptions on our APIs that isn't really a fault or null pointer exception, anything like that, right? But customers may experience some strange behaviors in our service. And we want to look into that, and we want to make sure we don't have the business logic bugs that cause customers to be unsatisfied. So what I'm going to do is, in this case, I'm going to use service diagnostics and look into the client behaviors and identify some unusual pattern. So I'm going to go back. I'll go to services page. And on the services page, I'm going to click on my front end. This is my interface. All my APIs go through this service. And I'm going to click on client pages. So this is integrated real user monitoring perspective in application signals. And what it does is it understands which web pages or clients are actually calling this service. Not everything, but this service. What APIs are being exercised and are they failing? We're also collecting golden signals here. Things like, for example, AJAX errors or page load latency, right? So in here, what I see is there is this one page that is having a strange spike in AJAX errors. So HTTP calls and something is going on. So I think my customers may not be served as well. Again, I'm going to click same pattern. You can see this is happening recurring, very similar pattern to other demos. I'm clicking on an anomaly, I'm getting my root causes, right? So in this case, what I got is all the user sessions that had that error. More interestingly enough, though, here I have traces that actually crossed the service, and I have enough information about what my backend service did and what it returned to the front end to cause this anomaly. I'm going to click through that and then investigate, again, as a responsible owner of this service. So what I see here is this is actually a 400 error, right? So again, one of those that isn't manifesting in any kind of failure anywhere in the system. I'm going to look into it. And I see here there's some strange behavior that get turned into a 400 error. So what is it? Let me look. Exceptions. So right here, what I see is somehow my validation logic, there's a business logic bug that we deployed that stopped customers from scheduling visits that are more than 30 days in advance. Who would know? Not always you would have a test that would test for something like that, right? So sometimes these things will be in production, and you may want to look around for this sort of unusual behaviors. So in this case, we found this validation bug by looking at non-faults but errors. The other way you can do this is by looking at your service and then looking at the service behavior that shows the golden signal. We call it errors. So faults, so you can sort on errors here and then see if you have any anomalies in basically a 400 responses, right? Not 500 faults, right? Again, one of the very common practices at AWS is to look around for these sorts of anomalies. With that, I want to bubble up a little bit and talk about overall AWS. We've introduced my application views yesterday as well. So both CloudWatch and AWS Console used to be very focused on resources, like underlying infrastructure resources. And we're now introducing the new focus for you to look at applications. And so application signals and my applications view are connected. And application signals is part of this focus on applications in AWS, and they're integrated. So when you look here at my services, you can see that they're tagged with an application, right? Like, what does that mean? So if you click on it, quickly switch over here. This is the view you get, right? This is my pet clinic application. It consists not only of my EKS services, DynamoDB, it has SQS, it has Kinesis. And so all of those are grouped into an application that you can view right from the start. And when you look at this application, it immediately gives you a sense of if it's healthy or not. If you created service level objectives, it will tell you if this application is healthy, right? It will also tell you how much it costs you to run this application. Also, whether it's secure or not, what compute resources and what your DevOps pipeline are doing. So this is an integrated view in AWS that integrates, so if you do your investigations in CloudWatch application signals, it is connected to my application view, right? It's connected to the overall story of how much it costs me to run, is it healthy, are my customers happy? In fact, you also get this view from the very beginning. If you click on the home page, there is now new widget, new entry point for all your applications. So if you create applications, they're multi-resource applications, and they have the perspective of security, monitoring and observability, as well as cost, right? So that concludes our demo. I want to invite co-presenters back on the stage. Come on over. The application signals, we announced it as the preview. So take it for a spin. Be a track star in the organization, in your 4x1. Try it out. Give us some feedback. We love feedback. Thank you for being here. Thank you for sharing your time with us. So we definitely want to welcome your feedback. Please fill out the evaluation form if you like the session. And what we're going to do is we're going to just come down the stage and answer all the questions you have. So please come on over, ask any questions you want. And thank you. Enjoy the rest of your reInvent.
Thank you.